In any massive engineering project, there's this invisible force that literally separates success from total disaster. We're talking about quality assurance and quality control. And hey, whether you're prepping for an exam or gearing up for your first day on site, getting this right is absolutely non-negotiable. So let's break it down.
So, what is this force? What's the real difference between a project that stands for 100 years and one that turns into a headline for all the wrong reasons? Well, the answer is all wrapped up in two powerful connected ideas: quality assurance and quality control. Okay, first step, quality assurance, or QA. Now, this is not about checking for mistakes at the end. It's about designing quality into the entire process, right from the very beginning. Think of quality assurance as being proactive. It's all about the activities you do before and during the work to make sure the process itself is set up for success. It's about preventing problems, not just finding them.
So what does a QA team actually do? Well, they're focused on the big picture. They're checking that the materials coming in are up to snuff. They're making sure the procedures are being followed to the letter. And they're obsessed with following established standards, from groups like ISO or the American Concrete Institute, because those are the rule books for excellence. The goal is simple: stop defects before they even have a chance to exist.
So, if you're going to boil it all down, remember this simple formula. QA is all about process control plus defect prevention. This is your game plan, your strategy for quality. All right, let's flip to the other side of the coin. If QA is the plan, then quality control, or QC, is the inspection. This is where you verify that the plan actually worked. It's the reactive part of the system.
So, quality control happens after the thing is built or the part is installed. It's a reactive job. Its entire purpose is to find any defects that might have slipped through, even with the best QA plan in place.
What does a day in the life of a QC team look like? Well, their focus is laser sharp on the finished product. They're out there performing tests, hunting for any defects, and checking if the final result actually matches the design specs. And ultimately, they're the ones who make the call. Does this pass or does it get rejected? And just like QA, QC has its own core equation. It's the hands-on work, testing plus inspection, all aimed at one thing: defect detection. This is your final checkpoint.
Okay, so we've got QA and we've got QC. Now for the aha moment. Let's put them side by side, because this is where you'll really get the core difference between the two.
And here it is, plain and simple. QA is proactive, it's focused on the process, and its goal is to prevent defects. QC, on the other hand, is reactive. It's focused on the final product, and its goal is to detect defects. One is about the system, the other is about the output. Now, they're not enemies. Think of them as essential partners working toward the same goal.
If you remember just one single word for QA, make it this one: prevention. It's all about stopping problems before they even start.
And for QC, the word is correction. It's the science of finding and fixing problems that have already happened. Prevention and correction. You need both. So why do we care so much about this distinction? Because QA and QC are the bedrock of what's known in project management as the iron triangle. It's the three pillars of any successful project.
See, in any project, you are constantly juggling three things: time, cost, and quality. And you can't mess with one without affecting the others. A project that's on time and on budget but has terrible quality, that's not a success. That's a ticking time bomb.
And this right here is the payoff. A solid QA/QC system makes sure you actually meet your technical specs, which means less costly rework and fewer delays. It keeps you compliant with industry standards, and it ensures durability and safety for the long haul. And most importantly, it prevents those catastrophic failures we all dread. This isn't just about ticking boxes. It's a system that saves money, time, and ultimately, lives. All right, enough theory. Let's get our hands dirty and see how this works in the real world. Here's a super common scenario you'll definitely encounter on a construction site. So, picture this. A fresh batch of concrete has just been poured for a building's foundation. A few weeks later, after it's cured, the initial lab results come back and, the strength looks a little lower than what the design calls for. This is where the QC team springs into action. They'll start running detailed compressive strength tests to get the hard numbers. The very first thing QC does is a simple but Absolutely critical calculation. They figure out the strength ratio. It's just the actual measured strength of the concrete divided by the strength that was required by the engineers. So now they have a number. What do they do with it? Well, they follow the rulebook. Industry standards say that if that ratio is 0.90 or higher, meaning the concrete has at least 90% of its required strength, it might be okay. But if it falls below that, it's an immediate rejection, and that triggers a full-blown investigation. And this is where it all comes full circle. The QC failure kicks off a QA investigation. The QA team now has to go back and look at the entire process. Was there a problem with the mix design? Were the raw materials, the sand, the cement, compromised? They perform a root cause analysis to figure out where the process broke down so they can make sure it never, ever happens again. So we'll leave you with this to think about. In a field like engineering, where safety and durability aren't just goals, they're absolute requirements, what is the true cost of just settling for good enough? As we've seen, having a strong system for both prevention and correction isn't just a good idea. It's the only way we build things that are truly meant to last. Thanks for tuning in.